Okay, here I'm going to document a little bit of what I'm doing for what I call the agricultural version of the ER50. So, what's happening is we've got a regular power cord, and it comes in power, ground, neutral. So the power is over here, the ground's there, the neutral's here. The neutral wire on this particular cord is ribbed, so you can always tell which one it is. On the to get a bit of an idea what the wiring schematic is like, what I've done is I've added a float switch. So the float switch goes down the center tube, the wires come up that center thing there. Your water in and gas out hoses are on this cap, which is not the long cap like I use on the health versions. In this particular case, I've upgraded the ER50 water torch to not include any transparent pipe, because the transparent pipe can't take the heat very well. It gets soft really fast, whereas this pipe can go to 60 degrees centigrade without too much issue. I've also upgraded the fittings so that I'm using, instead of high-density polyethylene, the black fittings, I'm using polypropylene fittings, which is much more compatible with the epoxy that I'm gluing into the PVC pipe. So we end up with a very good seal that will be very leak resistant under high temperatures. What happens under high temperatures is that the plastic tends to expand, and then when it contracts, it actually makes the hole bigger. Same with the end here. When the plastic expands and contracts, it will tend to be a leak coming out here, except I have an O-ring on the inside there that is much more flexible and seals even though the plastic expanded a bit. So terminals fixed, this fixed. As long as you can keep this cool under 120 degrees Fahrenheit, you won't have a problem with the ER50. So that brings me to an additional thing I'll show in just a minute. But first, with an ER50 in the health application, you can just have a regular timer switch, and you don't have to worry about liquid level control because you can see the liquid level in the sight tubes on both sides, and so you can see that there's enough liquid in. You don't actually need to see into the chamber because you can see the liquid level over here, and so you don't need a float switch. In an agricultural application, you actually need a float switch because you're going to leave the ER50 unattended for long periods of time. And in this particular case, this switch, when you turn it on, will bypass the timer switch and just leave the ER50 on. So then we're dependent on the float switch preventing the liquid level from getting too low, so that because that's what kills the electrolyzers. Is when the fluid level gets too low, the electricity can actually jump across between plates, creating an arc in here, and that arc can ignite the Brown's gas, so you get internal explosions and then heat, and then eventually, if you get the liquid level low enough, it actually can melt the plastic as the electricity is arcing, and you get a leak and it just destroys the machine. So it's not a bad thing to have too much liquid. It's a really bad thing to have too little liquid. So temperature, liquid level control, those are the main things we're doing with the to make an agricultural version of the ER50 so that it can be used unattended to bubble water for plants or fish or any other agricultural use. So in this particular case, the float switch is just simply an on-off switch, which is normally open, an on-off switch, magnetic switch, that when the liquid level starts to get low, it shuts off. It turns off. When the so as you add liquid, and that's another change I made, is I've made a 60 milliliter syringe, because when you go to add liquid in an agricultural version, you're going to add quite a lot at a time. So you just a bigger syringe for the water, so it makes it easier. So you go in, and this is the water fill fitting, and then this is the gas out fitting. So you'll just screw those in there. As the water level rises, eventually the float switch will turn on, and that will allow the current which is coming from this particular power, to go up through the float switch and then back down to this part here. This is an electronic relay, and as long as current is flowing through here, it turns on this switch. So the power comes from the float switch, from power through the float switch and to here, and then this wire goes to ground, which goes back over here. It's one of the ground wires. So when the float switch turns on, it turns on the electronic relay, which allows the power to go now from here to the capacitors. Then it goes through the capacitors, so from this side of the capacitor to this side of the capacitor, and then this power wire goes back to the full wave bridge rectifier right here on this corner. This side of the full wave bridge rectifier goes to the neutral. Okay, and then we have our power wire, the plus going out positive to this side, and the negative, which is this black wire here. So that black wire goes all the way over into here. That's the basic circuit. So we have initially the two on switches, either a timer or actually in this case, the regular on switch. They both turn it on, and when this switch is on, it essentially bypasses the timer. It just stays on. If this switch is off, then the timer, when you turn on the timer, then it'll shut off at that particular time. So either of these two switches will turn the electrolyzer on. This one keeps it on, and then when this one's off, this one will allow it to be timed. So those timers all fit into there. We've got our basic circuit. Now we come down to, again, keeping it cool. In order to keep it cool, I'm for the first time actually applying a fan to the electrolyzer. So what we have here is a 4-inch 110 volt fan, brushless fan, normally used for computers. And what I've done is put a ready rod and threaded it into the wood down there. Now it's actually long enough that it can go right through, and you can put a nut on the other end as well. But I actually threaded the wood, and then you just tighten the nut down there. Do this nut up so that you've got 3 inches of space from the wood down below up to the bottom of the nut, so that when the fan fits on there, it will be 3 inches up, and that will give a 1/4 inch of gap underneath between there. Now on the bottom side, I have these little 1/4 inch spacers, which you just put underneath here and screw in the screws to hold that in place. So you have a fan that's fixed in place, and the last thing you need to do is wire it up. Since it's alternating current, it really doesn't matter which of these two wires goes where, on which side. But one wire needs to go to this pin, which is pin number 3, electronic relay, and this other wire, the other wire, goes to here on the electronic relay. So whenever the electronic relay turns on and allows power to go through here, then power is here and the fan will turn on. So you'll know that the electrolyzer has power whenever the fan turns on. If the fan turns off when you think it should be on, then it's a good possibility that your liquid level is low. So you could check the liquid level and see if it's low, and if it is, well, then you just take this, put in some distilled water. It has to be pure water. So either really good reverse osmosis or distilled water only going into the machine to make the gas. And then you squirt the water in, and as soon as the water level comes up high enough, the switch should turn on. I would continue to put water level in up to about this height here in the agricultural version, so that you have a reserve of water in order to go several hours without having to refill. When you go to do your initial fill, you will undo this screw right down here, right down there, so that this bracket can be released and you can actually lift the water torch up and out. Unscrew the lid, which isn't screwed on tight right now, and mix up your lye solution with you'll see that in other videos. so that you can pour that in. It'll take about a liter of water to fill the machine to where the float switch should go, a little bit more actually, to where the float switch will turn on. In any case, after you put the water in, you tighten down the lid. Now in that particular case, and from then on, as soon as there's liquid in there, you want to make sure that the water torch is standing upright. And when it's standing upright, it will be like this. Okay? So the whole bracket will be like that, standing upright. So you'll have your switches, you'll have your fan, everything will be right there, like standing upright like that. Okay, so for construction, I'll just lay it down. When you're, obviously, you want to, when you're tightening the lid, make sure these holes are accessible toward the front for your water fill and gas out hose. I will include a handle with this particular kit so that you can actually put it on the top there, and it makes it a lot easier to carry it around. And the reason I don't actually screw it on is because this whole box, this whole crate needs to fit into a box. So there's some pieces like the fan and this handle which will have to be assembled onto the box after it's shipped to the customer. But that's the way we're doing it for now. So when you lift the ER50 up and you're going to remove the cap, you always make sure to disconnect these fittings here, because you don't want the cap to be turning and twisting these wires, because it'll twist the wires right off the float switch. So you always have to release the wires so they can freely turn, and then once the cap is put back on, then you would reconnect the fittings here. Always disconnect the fittings by firmly grasping on the plastic and pulling it apart. Don't pull on the wires, or you could just pull them right out of the fittings. So it's a good idea to hold the plastic and the wire actually, but the plastic mainly. So we'll unscrew the fitting at the cap here, and that's what the float switch looks like. And when it's down, there is no continuity, it's off, and when it's up, then there is continuity as it's on. So just to demonstrate, when it's down, it's off. When it's up, when the float rises, it turns on. So when you have enough water, it's on, and as the water level drops, it turns off. So that's on, off. When hooking these wires back up again, it doesn't matter which is which. They're non-polarity sensitive. So just hook one to one and one to the other. So just to be clear, the fan is actually only needed for applications where the ER50 will be operated for longer than 30 minutes at a time. If you're going to operate for less than 30 minutes at a time and allow it to cool down, you don't need the cooling fan. It'll stay cool enough, especially with this more heat tolerant version. And the fan, it uses about 220 milliamps of current, so as an efficiency person and just for having something that's not needed, I generally would recommend not using the fan unless you are going to be used for longer than 30 minutes at a time. In that case, definitely put on the fan. But for simplicity's sake, if you don't need it, you don't need to have it on there. When I'm wiring, I always try to wire in a what I call logical fashion. And in this particular case, the first thing I do is I put the ground from the switch and the ground from the input cable into the ground it to the box. Ground those all grounds together. So I do the grounds first, then I do the neutrals. In this case, we have a neutral coming from the timer switch, a neutral coming from the input power cord, a neutral coming from the full wave bridge rectifier, and a neutral coming from pin 3 here of the electronic relay. So those 4 neutrals will go together in that bundle. The next group of wires is the power. So the power in from the power cord, the power to the timer switch, and the power to the regular switch, the two-way regular on-off switch. So all those 3 go together. And now we have the power out from the switch. The before power was power going into the switches from the main power cord, and now we have the power going out from the switches into the wire which leads to pin number 1 on the electronic relay. So again we have first the grounds, then the neutrals, then the power in, then the power out from the switches is the final wiring needed to be done. So we have power out from the two-way switch, and the power out from the, which is a red wire, from the electronic switch there, and everything will be wired. So here it is ready to ship. Again, if you want to just turn it on for a certain number of minutes, you just turn it on with this switch. When you want to turn it on, this is on when it's down like that, off when it's like that. That is on, leaves it on, and it'll stay on until you turn it off. It doesn't matter if the timer is on or off, this switch bypasses the timer. Okay, so on, then if there's enough liquid in here, the float switch turns on this electronic relay, which allows the power to go from here to here, which then goes through the capacitors, and then back to the full wave bridge rectifier inside here, which then the neutral goes to the other side, so that's the AC side, and from the full wave bridge rectifier we have the positive coming out here and the negative coming out here. That lets electricity to flow and splits the water into the Brown's gas. Brown's gas comes out the top over here, and you do whatever you're doing with the Brown's gas. This handle can be strapped onto the top of here. The electrolyzer can be released here on this bracket, lifted up, water filled in the top here, so that actually I don't even think you have to undo this bracket. You can just lift it up, because this cap will screw right up through and out this, and then you can just fill directly into there. So then you can take and mix up your lye solution and put it in there. If you're going to be running it longer than a half an hour at a time, then you put the fan, mount the fan as I showed you before, over here, making sure that one lead goes to the number 3 on the electronic relay, and the other one goes to number 2. Number 2 is power to the fan, and number 3 is neutral going back to ground. So the fan will be turned on whenever the electronic relay is on. You can see the liquid level in the sight tube here. If you can't see the liquid level, the liquid is too low. You should be able to see liquid level. The float switch will turn the liquid level on and off automatically, so you really don't have to worry about that. If it won't run, you just got to make sure to put liquid in it. And that should pretty much do it for the agricultural version of the ER50. So here's what I did to fix the check valve problem. What happens is these check valves occasionally stop working, and then they allow water, when the vacuum forms in the ER50, when the hot gas is cooled, it forms a vacuum, and that'll suck water back out of the bubbler, back up into the tower, and could overfill the electrolyzer. So since we don't want that to happen generally, I actually put a valve in here so that it could happen deliberately, bypassing the check valve, but don't worry about that now. Generally speaking, you don't want that to happen, and you fill normally using a syringe, which I just, in this case, I keep right here. You just fill water in here. So you don't want water backfilling from the electrolyzer. So what I did to solve that problem, I'm going to be actually taking all this apparatus out and just having a hose going to my bubbler now, because the simple solution is what they call a duct bill valve. So what this is a little one-way valve which allows, in this case, air to flow into the electrolyzer, but doesn't allow the ground gas to come out. Incidentally, it can act like a little pressure relief valve if the pressure gets too high in the electrolyzer. You simply drill a 1/4 inch hole, and this particular duct valve fits right in that hole with a good fit. You have to kind of give it a twist as it goes down because there's a little piece of rubber that hits it. Oh, there we go. So now in this electrolyzer I have a pressure gauge, so you can actually see as soon as I turn on the electrolyzer the pressure rise. So gases are not going out that valve, they're going through the bubbler and then out through my cannulas. But you'll never have a vacuum form in the electrolyzer, because as soon as a vacuum starts to form, it'll suck air in from the atmosphere in that valve, and that's it.